Electrical Info YouTube channel. Subscribe and share. Today we see about 11 kV VCB testing methods, interview questions and answers. Here are some common interview questions and answers related to testing methods for an 11 kV vacuum circuit breaker VCB. These questions cover practical knowledge and troubleshooting, as well as testing standards and safety considerations. 1. What are the basic tests conducted on an 11 kV VCB? Answer. The standard tests for an 11 kV VCB include insulation resistance test. To check the insulation quality of the VCB. It measures resistance between phases and to ground. Contact resistance test. To measure the resistance of the VCB contacts when closed, ensuring low resistance for reliable operation. High voltage HV or dielectric test. To apply a high voltage across different VCB parts and verify insulation integrity. Timing test. To measure the opening and closing times of the breaker. Mechanical operation test. To check the VCB's operational reliability and endurance. Vacuum integrity test. To confirm that the vacuum inside the interrupter is intact and has not degraded. 2. How is the insulation resistance test performed on a VCB, and what are acceptable values? Answer. An insulation resistance test is performed using a megger. The megger applies a DC voltage, typically 500 volts to 5 kV, across the insulation, and resistance is measured in megohms. Acceptable values are generally above 100 megaohms between each phase and ground, but they can vary based on manufacturer specifications and site conditions. Low values indicate deteriorated insulation or moisture. 3. What is the purpose of contact resistance testing, and how is it done? Answer. The purpose of contact resistance testing is to ensure low resistance across the breaker contacts, which minimizes energy loss and prevents overheating. This test is performed using a micro-ohmmeter. Current is passed through the closed breaker contacts, and the resistance is measured in micro-ohms. Typical values for a healthy contact resistance are less than 100 micro-ohms. High resistance suggests contact erosion or poor contact alignment. 4. Explain the high voltage test procedure for a VCB. Answer. In a high voltage test, also known as a dielectric withstand test, a specified voltage, typically several times the rated voltage, is applied across the breaker insulation components, phase to phase and phase to ground, to check for insulation strength. This test is done with the breaker in the open position. If there is no breakdown or flashover during the test duration, usually 1 minute, the insulation is considered adequate. The test voltage and duration should follow IEC standards or manufacturer recommendations. 5. Why is timing testing important, and what does it involve? Answer. Timing testing is critical for assessing the opening and closing speed of the breaker, which directly impacts fault clearing time and system stability. Timing tests involve using a breaker analyzer to measure the duration for each phase to open and close, checking for uniformity and alignment with manufacturer specifications. Discrepancies in timing can indicate mechanical wear, alignment issues, or faults in the trip or closing coils. 6. What is the vacuum integrity test, and why is it essential for a VCB? Answer. The vacuum integrity test verifies that the vacuum inside the breaker's vacuum interrupter is intact and effective. This test can be done by a vacuum checker that measures the level of vacuum indirectly or by applying a high DC voltage across open contacts in a controlled environment. If the vacuum level is insufficient, the VCB may fail to interrupt arcs, leading to equipment damage or safety hazards. 7. Describe the procedure for conducting a mechanical operation test on a VCB. Answer. The mechanical operation test involves repeatedly opening and closing the VCB to assess its mechanical reliability and operational endurance. This test checks for consistent mechanical performance, looking for any delays or abnormalities in operation. The test is often done by energizing the trip and close coils, either manually or through automated cycles. This test ensures the VCB can handle a specified number of operations without mechanical failure. 8. What are the common signs of vacuum failure in an 11 kV VCB? Answer. Signs of vacuum failure include visible sparking or arcing during operation, reduced insulation resistance in the vacuum interrupter, change in contact resistance due to arcing deposits, difficulty in extinguishing arcs when breaking the current, leading to overheating and damage. Regular testing and vacuum checks are essential to detect these issues early and prevent potential equipment failure. 9. How can you troubleshoot a VCB that fails to operate electrically but works manually? Answer. If a VCB operates manually but not electrically, it may indicate issues with trip close coils. Check if the coils are receiving the correct voltage and measure their resistance. Control circuit. Inspect control wiring, relays, fuses, and connections. Auxiliary switches. Check auxiliary contacts for proper alignment and functioning. Protection relays. Confirm that relay settings and wiring are correct, as relays might prevent operation if they sense faults. A thorough inspection of these components can help identify the fault source. 10. What safety precautions should be followed during 11 kV VCB testing? Answer. Key safety precautions include: ensure the breaker is isolated and grounded before beginning any test. Use proper personal protective equipment (PPE) such as insulated gloves and face shields. Follow lockout-tagout (LOTO) procedures to prevent accidental energizing. Verify test equipment is calibrated and rated for the voltage level. Stand at a safe distance during high voltage and timing tests, as these involve moving parts and high energy. Here are some typical interview questions and answers focused on the acceptance testing of 11 kV VCB vacuum circuit breaker. 1. What is the purpose of an 11 kV VCB? Answer. An 11 kV vacuum circuit breaker (VCB) is used to control and protect electrical systems and equipment from overcurrent and short circuits by interrupting the circuit. VCBs use vacuum technology to extinguish the arc during circuit interruption, which makes them suitable for medium voltage applications like 11 kV systems, known for their reliability and low maintenance. 2. What are the key tests conducted for acceptance testing of an 11 kV VCB? Answer. Acceptance testing of an 11 kV VCB generally includes: insulation resistance test. Measures insulation quality. Contact resistance test. Assesses contact health. Timing test. Ensures operating time meets specifications. High voltage HV or dielectric test. Confirms insulation withstand. Mechanical operation test. Verifies mechanical functionality of operations like closing, opening, and latching. 3. What is the typical insulation resistance value for a new 11 kV VCB? Answer. Insulation resistance values can vary depending on standards and manufacturers, but generally, for a new 11 kV VCB, an insulation resistance of at least 1000 megaohms at 500 volts DC or higher is expected. Lower values may indicate poor insulation quality and potential for failure under normal conditions. 4. What is an acceptable contact resistance value for an 11 kV VCB? Answer. Typically, the contact resistance should be very low to ensure minimal power loss across the contacts. For an 11 kV VCB, acceptable contact resistance values usually range between 30 to 100 microohms. High resistance may indicate contact wear or improper alignment, which can lead to overheating and failure. 5. What are the typical timing requirements for closing and opening operations in an 11 kV VCB? Answer. The closing time should generally be around 50 to 100 ms, and the opening time should be around 30 to 60 ms, depending on the design and manufacturer specifications. Timing discrepancies can indicate mechanical issues like friction or improper lubrication, which could compromise reliability. 6. Why is the HV or dielectric test important, and what is the standard test voltage? Answer. The HV or dielectric test verifies that the insulation can withstand higher than operating voltages. For an 11 kV VCB, the standard test voltage is generally 28 kV AC for 1 minute or 75 kV DC for 1 minute. Failure in this test suggests weak insulation that could lead to a breakdown during operation. 7. How is a contact resistance test performed on an 11 kV VCB? Answer. Contact resistance testing involves using a micro-ohmmeter to measure the resistance between the closed contacts. The test is usually conducted by injecting a DC current, often 100 A, across the contacts and measuring the resulting voltage drop. This helps in detecting high resistance or poor contact surfaces. 8. What could cause a VCB to fail during the mechanical operation test? Answer. Mechanical operation test failures can be due to several factors, including improper alignment, mechanical wear of components, inadequate lubrication, weak or broken springs, and damage in the linkage mechanisms. These issues could lead to slower operation or complete failure to open or close. 9. Why is it important to perform an undervoltage trip test? Answer. An undervoltage trip test verifies that the circuit breaker will open if the control voltage drops below a certain threshold. This is critical in protecting equipment during power supply issues. For 11 kV VCBs, the typical trip threshold is 70–80% of the rated control voltage. 10. How often should acceptance testing be conducted on an 11 kV VCB? Answer. Acceptance testing is generally done upon initial installation or after any significant repair or overhaul. Afterward, periodic maintenance testing should be conducted based on manufacturer recommendations, operating conditions, or industry standards, typically every 1 to 3 years. These questions cover critical aspects of VCB testing and demonstrate a candidate's understanding of acceptance values, testing standards, and operational reliability for 11 kV VCBs. In an interview for the maintenance of an 11 kV VCB vacuum circuit breaker, technical questions are likely to focus on practical aspects of VCB operation, fault analysis, troubleshooting, and preventive maintenance. Here are some commonly asked questions along with suggested answers. 1. What is the purpose of a vacuum circuit breaker, VCB? Answer. A vacuum circuit breaker, VCB, is a type of circuit breaker where the arc quenching takes place in a vacuum. VCBs are preferred in medium voltage applications due to their ability to break currents and withstand high voltages. They are used to protect the electrical equipment from faults, overloads, and short circuits by disconnecting the faulty section from the power supply. 2. What are the primary components of an 11 kV VCB? Answer. The primary components of an 11 kV VCB include the vacuum interrupter, operating mechanism, spring or motor, contact arms, control circuit, insulating medium, and protective relays. Each of these plays a critical role in ensuring the VCB operates correctly to interrupt current flow during faults. 3. How does a vacuum interrupter work in a VCB? Answer. In a vacuum interrupter, contacts separate within a vacuum, creating an arc. The lack of gas in the vacuum suppresses the arc quickly, allowing it to extinguish as the contacts move apart. This process helps in breaking the circuit and prevents the current from flowing through, protecting the circuit from damage. 4. What are some common preventive maintenance tasks for an 11 kV VCB? Answer. Preventive maintenance tasks for an 11 kV VCB include cleaning the VCB and surrounding area to avoid dust accumulation, inspecting and lubricating moving parts to ensure smooth operation, checking the vacuum interrupter for leaks and wear, testing insulation resistance and contact resistance, Verifying the operation of auxiliary contacts and control circuits. Checking and calibrating the protective relays as per specifications. 5. What is contact resistance, and why is it important in VCB maintenance? Answer. Contact resistance is the resistance across the closed contacts of the breaker. High contact resistance can indicate poor contact alignment, corrosion, or contamination, which can lead to overheating and damage. Regular measurement of contact resistance is essential to ensure efficient current flow and avoid potential faults. 6. How would you test the vacuum integrity of a vacuum interrupter? Answer. Vacuum integrity can be tested using a vacuum test set, which applies a high voltage across the open contacts. If no significant current flows, it indicates that the vacuum is intact. Additionally, certain VCBs have a built-in vacuum indicator to monitor the vacuum condition. 7. What could cause a VCB to fail during operation, and how would you troubleshoot it? Answer. Common causes of VCB failure include mechanical issues, e.g., worn-out springs, faulty latches, electrical issues, e.g., insulation breakdown, high contact resistance, and control circuit malfunctions. To troubleshoot, inspect mechanical components for wear, check the control circuits for proper voltage levels, and test insulation resistance. Replacing worn parts and recalibrating as necessary can often resolve the issue. 8. Explain the role of protective relays in a VCB setup. Answer. Protective relays detect abnormal conditions like overcurrent, earth faults, and short circuits, and signal the VCB to open if such conditions occur. They ensure that the circuit breaker operates only when necessary to prevent faults from damaging equipment or causing unsafe conditions. 9. What types of tests are commonly performed on an 11 kV VCB during maintenance? Answer. Common tests include contact resistance test. Checks for low resistance across contacts. Insulation resistance test. Verifies insulation health. Timing test. Measures the time taken for opening and closing. Vacuum integrity test. Confirms the vacuum inside the interrupter. Operational tests. Checks open-close functionality and trip timing. 10. What safety precautions should you take when performing maintenance on an 11 kV VCB? Answer. Safety precautions include ensuring power is fully isolated and tagged out, wearing appropriate PPE, e.g., gloves, face shields, grounding the breaker before maintenance, following lockout-tagout procedures, keeping tools and test equipment properly insulated. 11. Describe how you would troubleshoot a VCB that fails to close. Answer. To troubleshoot a VCB that fails to close. Step 1. Check the control power supply and closing coil for proper operation. Step 2. Inspect mechanical linkages and springs for damage or misalignment. Step 3. Test the closing circuit for continuity and check relays and control fuses. Step 4. Verify that the closing signal is being properly received by the mechanism. 12. What is a common closing and opening time for an 11 kV VCB, and why is it important? Answer. Typical closing and opening times for an 11 kV VCB range from 50 to 100 milliseconds. Precise timings are important to ensure that faults are cleared promptly to avoid damage. If opening-closing times are too long, it may indicate mechanical issues or control circuit faults, and the breaker may need inspection and adjustment. These questions help gauge the candidate's understanding of VCB operation, maintenance procedures, troubleshooting, and safety practices. Being well prepared with practical examples and specific details will demonstrate proficiency in handling 11 kV VCB maintenance. Thanks for watching.